Now next topic I am going to consider is complete integrals. Integrals of the form I is equal to integral fx to the power of n f dash x dx and I is equal to integral f dash x over fx dx are known as complete integrals. Integrals of these two forms are known as complete integrals. In this integral we have fx to the power of n, and differentiation of the function is occurring here. Here we have 1 by fx and we have differentiation of the function in the numerator. So what we actually do is we put fx equal to t. So what we get is differentiate both sides. We will have f dash x is equal to dt by dx. Therefore f dash x dx will be equal to dt. And therefore I will be equal to integral fx is t to the power of n into f dash x dx. F dash x dx is dt. Now this integral can easily be solved. This will be t to the power of n plus 1 over n plus 1. N plus 1 is not equal to 0. That is n is not equal to minus 1. And this is equal to fx to the power of n plus 1 whole divided by n plus 1. N not equal to minus 1. So in this type of integrals we will be able to write the answer directly. If the derivative of this function occurs here, we will be able to write directly the answer. Fx to the power of n plus 1 over n plus 1. The formula of x to the power of n will be valid. If we have fx to the power of n into f dash x, we will use the same formula as we used for x to the power of n. Differential of x is 1. xn into 1 dx. So we will use the similar formula. So this will be x to the power of n plus 1 over n plus 1. And this formula is not valid for n equal to minus 1. For n equal to minus 1, that is fx to the power of minus 1, we will have this. So fx is equal to t will imply f dash x dx is equal to dt. And therefore I will be equal to integral f dash x dx is dt. And fx is t. And integration of 1 by t is log of t. Log of t. And this is equal to log of fx. This is defined only for t greater than 0. So we sometimes put a mod here. Plus c, and we can also add a constant of integration here. So if we have f dash x over fx dx, result will be log of fx. If we have fx to the power of n into f dash x dx, result will be fx to the power of n plus 1 over n plus 1. And if n is minus 1, we will use this formula and we will have log of mod fx plus c. Now first is integral of tangent x dx. Integral of tangent x dx. Now tangent can be written as integral of sin x over cos x dx. This is equal to, now differential of cos is minus sign. Differential of cos is minus sign. So we can write this as minus sin x dx over cos of x. So we have differential of cos x is minus sin x dx. Therefore, this is of the form f dash x over fx. f dash x over fx, f dash x over fx. So we can directly write this will be minus log cos x, minus log cos x, or if you take minus inside it will be log mod cos x to the power of minus 1, that is 1 by cos x. 1 by cos x is secant x, so we will have log mod secant x plus c. So now we know integral of tangent of x. Integral of tangent x is log secant x plus c. And similarly, integral of cotangent x. Cotangent x dx. This is equal to integral cos x over sin x dx. Now differential of sin x is cos x. So we have f dash x dx over fx. This is f dash x, this is fx. So we will use this one. So this will be log of mod sin x. This is a complete integral. Differential of this is occurring in the numerator. So this plus c. This is in this form. Now we move on to the next formula. Now third is integral of secant x dx. Integral of secant x dx. Now this is equal to integral. Now what we do here is we multiply and divide this by secant x plus tangent x. Why we are multiplying this by secant x plus tangent x will be clear in a few steps. Secant x plus tangent x dx, and this is equal to integral of secant square x plus secant x tangent x. This is secant x plus tangent x dx. So if we multiply secant x by secant x plus tangent x, this becomes this. And differential of secant x is secant x tangent x plus differential of tangent x is secant square x. So differentiation of this is secant x tangent x plus secant square x. So this is now a complete integral. This is f dash x over fx. So if we multiply and divide by secant x plus tangent x, this becomes a complete integral. And we can directly write the result. Answer will be log of mod secant x plus tangent x plus c. Clear? Note. Integral of secant x dx is equal to log of mod secant x plus tangent x. This can be written as minus log secant x plus tangent x to the power of minus 1. That is minus log 1 upon secant x plus tangent x. And this can be written as minus log 1 can be written as secant square x minus tangent square x whole divided by secant x plus tangent x, and this is equal to minus log, this is secant x minus tangent x into secant x plus tangent x whole divided by secant x plus tangent x. Now this cancels with this. This is equal to minus log secant x minus tangent x. So integral of secant x dx is log of secant x plus tangent x or minus log secant x minus tangent x. Minus log minus here. Minus log secant x minus tangent x. Both formulae can be used, but we in general use this one. Now next is integral of cosecant x dx. Integral of cosecant x dx, and this is equal to integral cosecant x into multiply and divide by cosecant x minus cotangent x. Cosecant x minus cotangent x over cosecant x minus cotangent x dx, and this is equal to integral, this will be cosecant square x minus cosecant x cotangent x whole divided by cosecant x minus cotangent x. Now differential of cosecant is minus cosecant x cotangent x, and differential of cotangent is minus cosecant square. So minus minus will be plus. So differential of this function is occurring in the numerator. This is f dash x and this is fx. So this is a complete integral, and this integral is equal to log of cosecant x minus cotangent x plus c, and this can in a similar manner be written as minus log cosecant x plus cotangent x plus c. This can also be written as minus log cosecant x plus cotangent x, as we did for secant x plus tangent x. So this is equal to this. Now we find alternative formulae for secant x and cosecant x. First I take cosecant of x. Cosecant of x dx. This can be written as integral of 1 upon sine x dx, and this can be written as 1 upon 2 sine x by 2 into cos of x by 2 dx, and this is equal to, now if we have an integral of the form 1 upon sine to the power of px cos to the power of qx, and p plus q is even, then we divide the numerator and denominator by cos to the power of p plus q x. I will take up this form later, but here we will use this. Sum of these two is even, 1 plus 1 is 2, even. We will divide both numerator and denominator by cos square x by 2. So what we get is, this is 1 by 2 into integral of, this will be 1 upon cos square x by 2 whole divided by sine x by 2 cos x by 2 whole divided by cos square x by 2 dx, and this is equal to 1 by 2 into integral 1 over cos square is secant square x by 2, and this is cos cancels, and we have tangent of x by 2 dx. Now differentiation of tangent x by 2 is secant square x by 2 into 1 by 2. Differential of tan x by 2 is secant square x by 2 into differential of inner function is 1 by 2. So we will take this 1 by 2 here, and this will be a complete integral. This can be written as this into 1 by 2 dx whole divided by tangent x by 2. Now this is a complete integral. Differentiation of this is occurring in the numerator. This is in the form f dash x over fx. F dash x over fx. So we will use the formula and get log of tangent x by 2 plus c. F dash x over fx, integral of f dash x over fx is log of mod fx, log of mod tangent x by 2. So this is an alternative formula for cosecant x, integral of cosecant x. Now we take up secant of x. So second is integral secant x dx. This can be written as integral 1 upon cos x dx, and we will change this into sine. This will be integral 1 upon sine of pi by 2 plus x. Sine of pi by 2 plus x is in second quadrant, and in second quadrant sine is positive, and this is an odd multiple, so we will have cos of x. So sine of pi by 2 plus x is cos of x. So we can write cos x as this. So this is equal to 1 upon 2 sine 1 by 2 pi by 2 plus x into cos of 1 by 2 into pi by 2 plus x dx, and this is equal to, now we will proceed in the same manner as in this question. We will divide numerator and denominator by cos square 1 by 2 pi by 2 plus x. So this will be equal to 1 upon cos square, this can be written as pi by 4 plus x by 2. Cos square pi by 4 plus x by 2, and divide this by the same term. So this will be 2 sine pi by 4 plus x by 2 into cos of pi by 4 plus x by 2 whole divided by cos square pi by 4 plus x by 2. And this is equal to integral, this will be secant square pi by 4 plus x by 2. This will be secant square pi by 4 plus x by 2 whole divided by, now this 1 by 2 I am writing here, and this cos cancels, and we get tangent of pi by 4 plus x by 2 dx. Now differential of this, differential of tangent is secant square x. So differential of tangent is secant square pi by 4 plus x by 2 into differential of the function is half. So differentiation of this is occurring in the numerator. So this is in the form f dash x over fx. So this can be written as log of mod fx. F dash x over fx, integral of f dash x over fx is log of mod fx. So log of mod tangent pi by 4 plus x by 2 plus c. So these are the two alternative formulae for cosecant x and secant x. Here you must note that we are writing cos x as sine of pi by 2 plus x and proceeding in the similar manner. Now we take up some questions based on complete integrals. So first of all, I prepare a list of formulae we have derived now. First is integral fx to the power of n f dash x dx is fx to the power of n plus 1 over n plus 1. Complete integral. This formula is not valid for n plus 1 equal to 0, that is n equal to minus 1. When n is minus 1, this becomes this. And integral will be log of mod fx plus c. And we have derived integral of tangent x is log secant x. Integral of cotangent x is log sine x. Integral of secant x dx is log of secant x plus tangent x, or you can use this formula, log of tangent pi by 4 plus x by 2. Integral of cosecant x dx is log cosecant x minus cotangent x, or you can use this formula, log of tangent x by 2. So you must remember these formulae. Now first question is integral of tan inverse x whole square over 1 plus x square dx. You can solve this by putting the inner function equal to t, that is tan inverse x equal to t, and you can solve the question. But this is a complete integral. How? Because differentiation of tan inverse x is 1 over 1 plus x square. So this integral can be written as tan inverse x whole square into 1 over 1 plus x square dx. So this is fx to the power of 2 into f dash x. Differential of tan inverse x is 1 over 1 plus x square. So this is fx to the power of 2 into f dash x. So we can directly write the result from here and write this integral as tan inverse x to the power of 3 2 plus 1 over 2 plus 1, that is 3 plus c. So we can directly, from this step, we can directly write the integral will be this, because this is a complete integral. And here what we notice, differential of log x is 1 by x dx. This is again a complete integral. In the beginning I am writing this as two separate functions, this into 1 by x dx. But with practice we will use the formula directly from this stage. So this will be, now this is fx to the power of 2 into differential of fx is, differential of log x is 1 by x. So this will be log of x to the power of 3 over 3, because this is in the form fx to the power of 2 into f dash x dx. Fx to the power of 2 into f dash x dx. So this will be fx to the power of 2 plus 1 over 2 plus 1 plus c, and we directly arrive at the result. So complete integrals are very useful. Now in this case what we see is, we know that integral of secant x dx is equal to log of secant x plus tangent x. Integration and differentiation are inverse processes. So if I differentiate this, I will get secant x is equal to dy dx of log secant x plus tangent x. So differentiation of log secant x plus tangent x is this much. You can directly see this by differentiating this. D by dx of log of secant x plus tangent x will be equal to, differential of log x is 1 by x, 1 by secant x plus tangent x into d by dx of inner function, that is d by dx of secant x plus tangent x, and this will be differential of secant x is secant x tangent x, and differential of tangent x is secant square x. So this can be written as secant x is common, and we get tangent x plus secant x whole divided by secant x plus tangent x. Now these two cancel and we get the secant of x. But you have a direct hint from integral of secant x is log secant x plus tangent x. So differentiation of log secant x plus tangent x will be secant x, because integration and differentiation are inverse processes. So d by dx of this must be this. So we have a hint from here. So what we do is we write this as integral of log secant x plus tangent x into secant x dx. This is fx and this is f dash x. So what we get is fx to the power of 1 plus 1 over 1 plus 1. So this will be log of secant x plus tangent x whole square by 2. We directly use the formula for n equal to 1. Fx to the power of 1 into f dash x. So this will be fx to the power of 1 plus 1 over 1 plus 1 plus c. Now next is this. So differential of this is not occurring in the numerator. So what we do is we change this into sine and cos. This will be 1 minus sine x over cos x whole divided by 1 plus sine x over cos x dx. And this is equal to integral. Now LCM is cos of x. So we have cos of x. So this will be cos x minus sin x. And again the LCM here is cos x. And we have cos of x plus sin of x. And this is equal to integral. Now cos x cancel, and we have cos x minus sin x whole divided by cos x plus sin x dx. And what we now notice, differentiation of cos is minus sin and differentiation of sin is cos. So differentiation of this is occurring in the numerator. This is f dash x over fx. So we can directly write the integral will be log of mod cos x plus sin x plus c. This is f dash x over fx. So integral of f dash x over fx will be log of fx plus c. So we change this into sin and cos, and we again arrive at a complete integral. Now next question is this. Now differentiation of this. What we notice, differentiation of 6 cos x will be minus 6 sin x, and 4 sin x, differentiation of 4 sin x will be 4 cos x. So what we notice, d by dx of 6 cos x plus 4 sin x, this is equal to minus 6 sin x plus 4 cos x. And if I take 2 common, what we get is this will be 2 cos x, and this term will be 2 is common, this will be 3 sin x. So what we see is differentiation of this is occurring in the numerator. We have to simply multiply and divide by 2. So this can be written as 1 by 2 integral 2 into 2 cos x minus 3 sin x whole divided by 6 cos x plus 4 sin x dx. This is equal to, now differentiation of this is this much, and this is occurring in the numerator. We have multiplied and divided this by 2. So this is 1 by 2 f dash x over fx. Integral of f dash x over fx is log of mod 6 cos x plus 4 sin x plus c. So you can, in short, solve this question as this. Now again, in this question, what we notice, differentiation of cos square x. Cos square x will be 2 cos x into differential of cos is sine. So we will have minus 2 cos x sin x. Differential of this will be 2 sin x cos x. So we have sin x cos x in this, we have sin x cos x in this. And 2 sin x cos x is sine of 2x. So we will take this common and arrive at sine 2x. We see this working here. So we have solved this mentally and we have understood that differentiation of this will be in terms of sine of 2x. How? D by dx of a square cos square x plus b square sine square x. This is equal to a square is common and differential of this 2 cos x into differential of cos is minus sin x plus b square into 2 sin x, differential of sin x is cos x. This is equal to, now we take 2 sin x cos x common. And what we get is 2 sin x cos x is common, we have minus a square. And 2 sin x cos x is common, so we will have b square here. So this can be written as b square minus a square into sine of 2x. So what we notice, differential of this is b square minus a square sine 2x. So if we multiply and divide by b square minus a square, this will be a complete integral. So what we do is we multiply and divide by b square minus a square. This will be equal to b square minus a square sine of 2x whole divided by a square cos square x plus b square sine square x dx. And this is 1 upon b square minus a square. Now differential of this is this. So we have f dash x over fx and its integral will be log of fx. So log of fx is a square cos square x plus b square sine square x plus c. So this will be the answer. But you must be able to note that differential of this is, in both these we will have 2 cos x sin x. 2 cos x sin x. So this will be sine 2x. So sine 2x will be common and we will get this. So if you are able to note that differential of this will occur in the numerator, then you can reduce this question into a complete integral and solve it in a shorter way. Now you can try these questions yourself. Differential of this will be 2x plus 1. So if we take 2 common from this, this will be 2x plus 1. So this will be fx to the power of half into f dash x. And differential of ex plus e to the power of minus x is ex e to the power of minus x into differential of inner function is minus 1. So differential of this is occurring in the numerator. This is in the form f dash x over fx. And similarly, you can solve this. Differential of 1 plus cos x. Differential of 1 is 0, differential of cos is minus. So multiply by minus and adjust minus here. It will be a complete integral. And again, we know integral of cotangent x is log sine x. Integral of cotangent x is log sine x. So log sine x, differential of log sine x will be cotangent x. Log sine x is 1 over sine x into differential of inner function, that is cos x. But you have a hint from the formula of integration. Integral of cotangent x is log sine x. So differential of this is this, and we will be able to reduce this into a complete integral.